Let's discuss the three tree traversals Leetcode problems. Leetcode 94 is the Inorder Traversal. Leetcode 144 is the Preorder Traversal, and Leetcode 145 is the Postorder Traversal. Before we discuss, please share, like, subscribe, and hit the bell button for notifications. Also, I have added a lot of quizzes to the community page. Please check it out. So the in-order, pre-order, and post-order traversals are basically with respect to the root node when it is processed. Whether root node is processed in the middle, before, or after. So that's what determines. If it is processed in the middle, it is called in-order. So in-order traversal is you process the left, root, and the right. And the pre-order is you process the root first, and then the left, and then the right. And then the post order is left, right, and then the root. So it's all with respect to how when the root node is processed. So the recursive solutions are pretty simple, but they're very inefficient, and I think that is not expected in the interview. So you have to come up with the iterative solutions for these traversals. And also these are all depth first searches. They are not breadth first searches, because you go deep into, once you pick the left root node, you go further and further. You don't do the level order traversal, which is the BFS. Level order traversal is the BFS, and but that is not one of the three traversals we are discussing in this video today. So in the case of in-order traversal, I call it as two while loops, because you use the inner while loop to go to the leftmost node. So all of them, because these are all DFSs, they need stacks, not queues, which is the preferred data structure in the case of BFS. So you have a node stack, and while root is not null and node stack is not empty, so you go further, and then you actually keep, if the root is not null, you push the root, and then go left. You keep doing this until you hit the null pointer. So in this case it is 1, 2, and 4. Now you hit the null pointer. So then you pop you're done with the leftmost thing, then you pop, and then you push that value, and then move to the right, basically. So this is the in-order traversal, and for this binary tree, the in-order traversal is basically like you push 1 to the stack, 2 to the stack, and then 4 to the stack, and then pop 4 and process, then pop 2 and then process, and then push 5 onto the stack, because there could be whole subtree under the 5, so that's why you have to push 5 first. But now you encounter it is only null, so you pop, and pop 5, and then pop 1, and because it's in order traversal, so 1 comes, and then you push 3, and then because there's no left node, and then you have to process the root node, so you pop 3, and then you push 6, and then pop 6, so it becomes like 4 2 5 1 3 6. That is the order. So in the case of pre-order, you process the root node first, and then left, and then right. So it looks similar to, you can see it as actually BFS with stack pattern, but it is a stack. So if it is root node is null itself, then you return back and empty vector. Otherwise you push the root node, and then while the stack is not empty, you pop the root node, and then you process that one first. So in the pre-order, root is processed first. Now then you push the right one first, because it is a stack. the way you pop is in the reverse. So because you need to process the left next, but because it is a stack, you need to push the right first and then the left next. So in the while loop, as long as the stack is not empty, it gets picked up in the right order. So I traverse the preorder traversal. You process one first, and then push 3 the right node, and then push 2, and then because you have to process the root node first, you process 2, and then you right node you push 5, and then push 4, and then you pick up 4, and then you pick up 5, and then you process the root node 3, and then you push 6, and then you pop 6. So it is 1 2 4 and then 5 3 6. So in the case of post order traversal, this is a reverse pattern. We have to reverse it by, so if it is null, you will see the reverse at the end. You still actually this is the simple one. Actually, I wanted to, this is not a, this is a recursion pattern. So this is how simple it is in the case of a recursive solution. So you, if it is null, you return, otherwise you recursively process the left node and then the right node and then the root node. But this is the one which is a iterative solution. So you still have the stack, and then you push the root node, similar to BFS, but with a stack. So you pop the node and then process. You are doing the reverse actually. You are processing the root node first, but we'll reverse at the end. So root node goes to the end basically, and then you push the left node first because you need to process the right node first because you are going to reverse, and so, and then at the end you do the reverse to get the post order reversal. So you are processing for the same tree, processing node 1 and then pushing left to the stack, and then you push the right and then pick up 3 and then pick up 6, and then process 2 and then push left 4 and then 5 and then pick up 5 and then pick up 4, and then basically now you start reversing. So the result, so you become 4 5 2 6 3 1. That is the post order traversal. Let me know if you have any comments. Otherwise, I will see you in the next video. Bye.